You're welcome back once again to my channel. This is your man Alam, and in today's tutorial we shall be looking at some examples of ordinary differential equations using the different methods of solving it. In my previous video, which is a recent one, we look at the variable coefficient, how to prove it, and how to solve some one or two examples in there. So here we want to take these examples and then solve them out. Now, taking the first question, to find the solution y to the IVP t y prime plus 2y equal to sine t all over t. It is an IVP, that is initial value problem. That's the meaning of IVP, initial value problem. It is asked that you find the initial value problem when you know t and when you know y. Then you find the initial value problem, because the general formula c is found inside, but in this we will find the c and substitute inside. So without much ado, let's solve the question and then we are good to go. Now we have ty prime plus 2y equal to sine of t all over t. Divide through by t. Now divide through by t, you have y prime plus 2 over t all y is equal to sine t over t multiplied by the t, that's the one we are dividing by, which means that we have y prime plus 2 ty to be equal to sine of t over t squared. Now multiply through by u, that is using the integrating factor method, which is we represent the factor by u. So multiply through by u, I have uy prime plus 2 over t multiplied by u, which is equal to, multiply this by u, get sine of t over t squared. Further elaborating, we let the coefficient of this, that is the coefficient of y, which is 2 over 3 u to be equal to u prime. So I can substitute inside. So therefore I have u y prime plus u prime y, and this is equal to u sine of t all over t squared. So I can factorize this. As u y all prime is equal to u sine of t all over t squared. In the previous I've explained that this, when you are differentiating using when you maintain this and you differentiate y, you get y prime. That is, maintain u and differentiate y, you get y prime. And when you differentiate u, maintaining y, you get u prime. So we are getting back this. So that's how we factorize it to get the y, uy all prime. Okay, so we now find u, but u is equal to e exponent the integral of the coefficient of uy, the coefficient of uy, which is 2 over t, the coefficient of this, which is 2 over t. So I have 2 over t dt, which implies that u will be equal to e exponent 2 ln of t dt. That is, when I factorize the two out, I have 2 1 over t, and integral of 1 over t is ln t, so that when I differentiate I will get back my 2 over t. So this is further equal to, sorry, t is not there, Alright, so this is equal to e exponent ln of t all squared. So the 2 here is going up here. Alright, and this is now further equal to e ln. The ln will cancel the e, leaving only t squared. Now we substitute this u back into this equation here. So let's say this is equation 1. We substitute u back into that equation, and then we have t squared y all prime is equal to t squared sine of t all over t squared. Now this t squared is going to cancel with this t squared, leaving t squared y to be equal to sine of t. Now integrating the right hand side and differentiating it again, we integrate this and we differentiate. So it means I have t squared y to be equal to integral of sine t, and you differentiate it again. Now integral of sine is negative cost, so I have ty all prime. Remember, this is all prime is equal to integral of this is negative cos t, and differentiating it, grouping like terms, I have is equal, that's taking this come across, I get positive cost of t prime is equal to 0. Now t of y, that's factorizing the whole thing, get cost equal to 0. So we call this as the total derivative. Then we can say let phi of ty to equal to t squared y plus cost t. That is whatever that is inside the bracket here. Whatever is inside the bracket here is what we call the potential function. Now, if this is phi t of y is equal to this, then phi of pi is equal to 0, just from here. Okay, so taking integral on both sides, I have phi prime with respect to the t is equal to 0 to t, which means that phi will be equal to c, but I know that phi is t squared y plus cost, and which is equal to c. Because I'm looking for y, I group like them by sending the cost across the equal sign. So I have t squared y is equal to c minus cost t, divide through by t squared, and this is equal to t squared minus cos over t squared. So this is the general solution for the differential equation we are solving. But the question said that was to find the IVP. So from the IVP, we can see that t is equal to pi over 2 and y is equal to 2 over pi. So we substitute inside to find c. Okay, so let's do that. Y is 2 over pi, and this is equal to c over t, and t is pi over 2 all squared minus cost of t over pi on 2 all squared. This can further be elaborated as y, that is which is 2 over pi, equal to c over pi squared over 4 minus cos pi over 2 over pi squared. So this is pi squared over 4, because we are expanding, we are sending the squared inside. Now we multiply through by pi over 4, multiply through by pi squared over 4. So I have pi squared over 4 multiplied by 2 over pi is equal to c over pi squared over 4 multiplied by pi squared over 4 minus cos pi over 2 over pi squared over 4 multiplied by pi squared over 4. This is going to cancel this. This is going to go with this, and one of these goes with 1, leaving pi. Then 2 goes with itself 1 into here 2. So it means I have pi over 2 to be equal to c minus cos pi over 2. Now cos pi over 2 is equal to 0, because pi is 180, so we have 180 divided by 2, which is equal to cos 90, and cos 90 we know is 0. So therefore I have pi over 2 to be equal to c minus 0, implying that c is equal to pi over 2. Hence the IVP will be, that's y of t, will be equal to pi on 2t squared minus cos pi on 2 over t squared. So we have replaced the c inside our question, and then the first part is solved. So write as required, students will like writing that one. Example 2. Find all the solutions to the differential equation. Now, what we should know is that when they say find all the solutions, it means that c is found inside the answer. This is not IVP. They didn't give you the t, they didn't give you the y. So c is there. C can be any value, it's any constant at all. So that's why it is all solutions. So we are coming to find y in terms of the c will still be in the solution. Now we have ty prime is equal to negative 2y plus 4t squared. Divide through by 2, t. So divide here by t, divide here by t, divided by t. So I have y prime to be equal to minus 2y over t plus 4t. Okay, grouping like terms, I'm sending this to the left hand side. So I'm y prime plus 2 over t y is equal to 4t. Now multiply through by the integrating factor u. Multiply through by the integrating factor u. So I have u times y prime plus 2 over t times u y is equal to 4 times u. That's this. Now we let the coefficient of y to be equal to, that is 2 over t u to be equal to u prime. So we substitute it inside the previous one, which is this one. So I have uy prime plus u prime y which is equal to 4ut. Fine. So I can factorize this as u y all prime. So when I expand it using the differentiation, I'll get back my normal thing, which is equal to that. Now let's find u. U is equal to e is the integral of the coefficient of y here, which is 2 over t dt, and this can be equal to e exponent 2 1 over t dt. So the integral of 1 over t is lim t. So I have 2 lim t, and this can be further written as lim of t squared. Alright, implying that u is equal to t squared, because the lim will go with this, leaving t squared. Now we substitute this back into equation 1. We substitute it into equation 1. So let's say this is my equation 1. We put it inside that equation. So I rewrite it here. So u y all prime is equal to 4ut, and now we know our u to be t squared. So we substitute it inside. So I have t squared y all prime is equal to 4t squared times t. I'm going to have t squared y all prime is equal to 4t cubed. 4t cubed. So that's wonderful. We now integrate and differentiate the right hand side. So this is what we mean. It's equal to integrate and you differentiate at the same time. So now I have y t squared y all prime is equal to the integral of 4t cubed is 4t exponent 4 over 4, or still what? Differential. This 4 cancels this, leaving t squared y all prime is equal to t exponent 4 all prime. Now I group like terms, so I'll send t exponent 4 across the equal sign. So I have t squared y all prime minus t exponent 4 all prime equal to 0. Now factorize everything into one bracket. I have this equal to 0, and this is the total derivative. So if I say phi of ty to be equal to t squared y minus 4 x raised to the power t raised to the power 4 is the potential function. And if that's the case, then means phi prime is equal to 0. Integrating both sides, I have phi prime with respect to t is equal to 0 with respect to t, and phi will be equal to c, implying that t squared y, because the phi here is equal to this. So now that we got phi to be equal to c, I rewrite it as t squared y minus t exponent 4 is equal to c. We are looking for y, so therefore we group like terms and then we divide through. So t squared y is equal to c. This negative going across becomes positive t exponent 4. So we divide through by t squared, divide here by t squared, divided by t squared, and then your solution, which is this, is going to cancel this, leaving c over t squared plus this, and then this was going to go into itself 1 into here, leaving t squared. So I now have y to be equal to c over t squared plus t squared. And this is the general solution which we are looking for, but it can be rewritten as ct exponent negative 2, okay, plus t squared. For objective sake, you might not find this, but you get this, okay, and this is still the general solution, because c here, it can represent any other IVP, and if the t and the y is given, you can find the value of c, and that becomes a particular solution. Now let's look at the last example. The last example says that we to find the IVP of y prime equal to negative 3y plus 1. You can see that this is a constant coefficient because the 3 here does not depend on t, but it's a constant, right? And then we have been given t to be 0 and y to be 1, so it's an IVP, so we can solve it and we are good to go. So we have the question as y equal to negative 3 y plus 1. Grouping of like terms, 3y is equal to 1. Multiply through by the integrating factor u. So I have u multiplied by y prime, 3 times u, y is equal to 1 times u, which is u. Now let 3u to be equal to u prime. You can see the trend is always showing. We are always picking this and equating to u prime, okay, so that we can easily factorize it. So u prime y plus u prime y is equal to u. I can now factorize everything inside one bracket and call it a prime. It's equal to u. So we'll say this is equation 1. Maybe this is star. Okay. Now from here we can find u. We can find u, but u like is equal to the integral of the coefficient of y, which is 3. So I have 3 t. This is equal to integral of e exponent. Integral of 3 is 3t. Okay, so my u is equal to e exponent 3t. We substitute it into equation 1. We substitute into equation 1, and I'm going to have u, which is e exponent 3t y all prime to be equal to e exponent 3t. Now we integrate at the right hand side and differentiate. So we have this to be equal to the integral of e exponent 3t, and we differentiate it at the same time, implying that e exponent 3t y all prime is equal to the integral of e exponent 3t is e exponent 3t over 3. When you are integrating the limb, the e, you differentiate the top and divide it with the down. So differential of 3t is equal to 3. So you divide by the whole thing again, so you have 3t over 3. So that's the integral of this one. Now we differentiate it again. Furthermore, we group like terms, and this is going to be equal to, I'm bringing this one across the equal sign, and that is going to be minus e exponent 3t over 3 all prime equal to 0. Factorizing everything into one bracket, I will have equal to 0, and we call this the total derivative. Now let phi of ty to be equal to the potential function. Okay, so if that's the case, then phi prime is equal to 0. So taking integral on both sides of phi, that's 0 dt, implying that phi is equal to c. If phi is equal to c, it implies that e exponent 3t y minus e exponent 3t over 3 is equal to c. I'm looking for y, so we group like terms, right? So my y, e exponent 3ty will be equal to c plus e exponent 3t over 3. Now we go further by dividing through by e exponent t, because we are looking for y. So we divide here by e exponent 3t divided by e exponent 3t, and divide this by e exponent 3t. Okay, and when you have done that very well, you have y to be equal to c over e exponent 3t plus 1 over 3, because from here this e is going to go with this, leaving only 1 over 3, and can be rewritten as y of t to be equal to c e exponent negative 3t plus 1 over 3, which is the general solution we are looking for. General solution because this c is not known. Now the questions actually specify that we should find the IVP when y of 0 is equal to 1. It means that t here is equal to 0 and y is equal to 1. So we substitute that and find c. So y is 1, which is equal to c e exponent 30 plus 1 over 3. 1 is equal to e exponent 0 will give me 1, so c plus 1 over 3. I'm looking for c, so I group like terms. So c is equal to 1 minus 1 over 3, implying that c is equal to 2 over 3. Now the IVP of the equation will now be y of t to equal to c, and c is 2 over 3 e exponent negative 3t plus 1 over 3. Hence our solution is being proved. If you want to go further, you can factorize 1 over 3 out, leaving 2 in the bracket this, and you are still correct as required. Don't forget to hit the subscription button. More to the point, hit the notification button so you'll not be left out when I release any other video. Don't be greedy. Help me to promote the channel. Have a nice time.